against our manifold pressure. So I'm going to be showing you how to write a custom math equation. We're also going to be taking a look at the overlay feature. So if we want to compare two different runs at the track, let's say we're at the drag strip and we have a run that we go 9.5 ET and the next run we go 9.2 ET. We want to know why we have went faster. So using the overlay feature, we can take these two data logs, overlay them on top of each other, compare everything in the data log. So we can see what the boost was doing, what the throttle was doing, what the ignition timing was doing. We can see everything. With the overlay feature, it's going to be an invaluable feature. It's going to help you go faster because you can directly compare your runs at the track or even on the dyno. If you're dyno tuning and you're not sure why you have a difference between two dyno runs, you can simply do an overlay feature and very quickly see that difference. I'm going to be walking you through how to do that in this video. It's going to be a lot of great information. You're definitely going to want to use this in your AEM data software. So without further wait, let's jump into the video so we can check it out.
Okay, so let's get started here. We're going to be taking a look at using our AEM data software and adding a math expression that we can use for monitoring purposes as we're doing our tuning. It's going to be really useful. This will just be illustrating one of many, many math equations you can add into your AEM data based on, again, the data that we're already taking in here. So we're going to be taking two or more channels, putting them into a mathematical equation to spit out a calculated channel that we can put into our data log that we can use again, for monitoring or for tuning purposes. So what I'm going to be looking at here and showing you in this video is going to be our fuel pressure differential. Now we covered the concept of that in EFI Basics, and that's going to be where we maintain the base pressure at all operating ranges of our engine based on different vacuum or load ranges. We're going to be having a vacuum line to our fuel pressure regulator. That's going to vary the fuel pressure at a 1-to-1 ratio to manifold pressure. And what we're going to find is the base pressure, which is going to be what we find at 0 psi, or if we have the engine running, pull the vacuum line off of our fuel pressure regulator, we're going to be seeing what that base pressure is at, and let's just say it's at 50. We should be maintaining that 50 psi injector pressure differential across all operating ranges, and that's going to be assuming that our manifold pressure and our fuel pressure are going to have that 1-to-1 ratio. So as we go up in manifold pressure, our fuel pressure will rise at that same rate of 1-to-1. Same thing with the vacuum. It's going to decrease at a rate of 1-to-1. And if we find that our fuel pressure is tracking correctly, we're going to find that our fuel pressure differential is going to be maintained at all times. And then we're going to be hitting and flowing the rated amount from our injectors. So let's say at 50 psi, our injectors flow 1,000 cc. We're going to be able to get that. So how do we go and add this to our AEM data here? Well, it's pretty straightforward. I'm going to go into my fuel tuning tab. I'm going to add my fuel pressure differential into this tab. Now you have to have your fuel pressure sensor add it to your fuel system. You can't do this unless you have it to add it to your fuel system. And I personally recommend that you add a fuel pressure sensor to your fuel system and wire it into the Series 2 and then configure it. So real quickly, if we jump into our calibration file,